Hey everyone, welcome to the, I guess, 3 p.m. Eastern session. I'm here today to talk to you about the WAF versus RASP. If you don't know what those terms are, that's fine. I'll definitely dig in them a little bit further. But first off, I wanted to kind of introduce myself. I'm David Lindner. I'm the Director of AppSec at Contrast Security, also known as Golf Hacker Dave, and numerous platforms, including Twitter. I've been around the application security space for the better part of 20 years. And, I've seen things come and go and seen kind of the waves, the way we do development and all that good stuff. So, jumping right in, not so breaking news. Everyone here is totally in the news, understanding that, our applications are under attack. They're vulnerable. And for years and years and years, we've tried to, either manually or programmatically or adding software detections, all this stuff to find and prevent vulnerabilities from being attacked and exploited, right? But there's some things that I wanted to talk about, from a data perspective before I really dig into, just a small piece of the layers of protections that we've put in place over the years, and some of that comes down to, the average application. If we look at development these days, the average application is only 21% of what we would consider like custom code, first party code, whatever you might call it today, right? And in that code, we're seeing quite a few vulnerabilities. And then the rest, the bottom part of that iceberg, if you will, the 78 or 79% is library code. So we're bringing in all these libraries from, semi-trusted, trusted, untrusted sources. We may need one piece of functionality from this library. That library may be 1 million lines of code, and we're only using, one class or method. And the reality is there's not necessarily nearly as many vulnerabilities in what we're pulling into our custom code. So, you look at, year over year, and like I said, I've been doing this for a while. I was in consulting for some time, and the reality is the number of serious vulnerabilities or vulnerabilities in general in our software applications hasn't really changed. Things have shifted a little bit. We've added all sorts of standards. It started way back with some of the formal methods, and then you start talking about OWASP top 10 coming out. For those of us in AppSec have heard about the top 10 for years and years and years. It kind of started out as a, hey, you might want to think about these things, to now it's in like standards bodies, right? Like PCI and NIST 853 and things like that, where it may not have been meant to be there. But, we've tried to do all these things over the years to really help drive, security expertise and building secure software. And now if you look at the space, we're doing things much, much more quickly. We're talking DevOps, DevSecOps, shifting left, all these, new terms. But really what it comes down to is we're adding more and more engineers. We're writing more and more code. And we don't have nearly as many, security folks that are needed to keep up with that growth on numerous spectrums. So, one nice thing about working for a software security company is we have a lot of data, right? We see a lot of things with the different applications that we're either, detecting vulns or protecting things against. So I'm a big data person. I like to pull data out and just really like dig into that data. And, based on a year's worth of data from all of the applications that we're protecting, there's, over 13,000 attacks detected per application per month. That's a ton. But if you think about it, a lot of that is, just drive-by scanning and, script kiddies and things like that are going on the internet. And some of it could be like legit, I'm assessing my application, or bug hunters, or what have you, right? But, as far as what's actually landing, only 98% or 2% of those attacks are actually landing in targeted vulnerabilities, right? So you can see over time the increase in the attacks that are detected. The interesting thing to note is, we've all been kind of working from home and this whole COVID thing. And if you look around the March, April, into May timeframe, the attacks detected have gone up dramatically. I don't know if there's a correlation there, but it's one way for me to look at this data and be like, oh, people are at home, maybe they're being a little more malicious or testing things a little more, right? But you can definitely see that those numbers are increasing. The vulnerability types by language are also targeted differently, which at first glance I'm like, why is that? Do they know what language it is? Well, sometimes they probably do, right? You may be targeting different things like EL injection and OGNL injection and stuff is like a Java type of thing, right? So you're gonna naturally see more attacks against those sorts of vulnerabilities. But the other ones like SQL injection, path traversal, things like that, I would expect them to be a little bit more close. Cross-site scripting is fairly similar. But for the most part, it does seem to matter, at least at a high level, what kind of programming language you are using in your code base. And then we kind of overlay it, right? So what's the likelihood that my application or API is getting attacked of what kind of attack type? I don't really want to dig too far into, the details of the data. From my perspective, I want to dig into WAF and RASP. That's what we're here for. But as you can see, the attacks coming in are, in reality, some of the more egregious vulnerabilities, the ones that can lead to a bigger payout, right? Your injection type vulnerabilities. And frankly, a lot of those types of vulnerabilities have quick and easy tooling that you can spin up in like a burp repeater or intruder or something like that will easily allow you to just push a button and throw a bunch of payloads at a system. But as I kind of mentioned, early on, we're at this precipice or this place in this software security space where we're calling it more of a crisis. We have some specialized security staff. They're few and far between. There's lots of burnout. People move around quite frequently. There's tons and tons of tools. None of them work exactly how you would want them to work in your environment. So then you have to maybe pull in a few tools to cover the few edge cases that may not work in the tool that you had budgeted for, or you have to supplement with manual processes, which requires your specialized security staff. And at the same time, we're developing code at a rate that is way above where the budget, the tools, and the specialized security staff are, right? I think the last number I saw was there's around 30 million professional developers, and that's like full-time, that's all they're doing, development in their professional lives. And on average, they're writing 10,000 lines of code a year. You start adding that up, and that starts to become a really massive number. And that's new lines of code. They're fixing old lines of code too, right? So it's a thing that we've been talking about. Software is eating the world, right? It truly is, and we've got to think of better ways to help secure that software, knowing that we're way behind on the tools, budget, and security staff front when it comes to the amount of code that we're churning out. And there's studies to back that up. Right? So BSIM, Build Security and Maturity Model, is basically, it goes into organization and sees how your security program is doing, right? And they interviewed 122 of the organizations that went through their BSIM process. And out of those 122, on average, they had one software security person for every 73 developers. If that's not astounding to you, it is to me. But think about that, right? So I've got one person per 73 developers who are writing close to 1 million lines of code a year, new code, plus they're fixing all their old code at the same time. And I have one person attributed to all of that work, right? That's not sustainable. And it could be multiple languages, multiple tools, processes, threat models, design reviews, you name it, right? Not sustainable. So now we'll dig into the crux of what I wanted to talk about today. So what problem are we facing? We started facing this problem way back. I've been in this for a long time. Back in the days of, oh, we're getting pretty good at firewalls, right? We're getting pretty good at just saying, no, we can't allow any of that in or out. And then the web was kind of a thing, right? And it's like, oh, well, we have to open this hole for port 80 and 443 in our firewall. And oh, it's layer 7. So we can't really do much with that. And oh, it's encrypted. So what do we do now, right? So for the longest time, we were just perplexed and like, oh, we'll just open it. It'll be fine. People are just viewing their account statements and their bank account information and things like that. And then things started to really go downhill from there fast. So we're like, oh, we're really good at firewalls, right? So what should we do about that? So that's kind of where the WAF was born, right? The web application firewall. We're good at firewalls. Why not do something along those lines, but dedicate it for applications or web type traffic? So around 2002, mod security was kind of the first real, I guess, WAF, if you will, right? So we, like I said, we tried to create this firewall-like thing to solve a networking problem that really wasn't a networking problem. And so we created this WAF to detect things at layer 7, which we didn't really have with our other types of firewalls that were, at much lower level review of the traffic coming in and out. So again, a WAF is the layer 7 stuff. It's used to stop scanning, potential attacks against your application layer. So the traffic coming to and from your web and API type applications. There's some tuning that needs to be done with this, and a lot of alerting. The one thing that a WAF has is this alerting mechanism, and right away it's like, oh my gosh, there's a lot of things going on. There's a lot of alerting. So we started tuning things away because alert fatigue is also real, right? And if you start getting all these alerts, we're getting all these false positives. We're not even sure what to do with it. But we know we need it, right? Because our other firewalls can't do anything with this traffic. And we know that there's attacks going on because every report from, the beginning of time has told us and showed us the data to back that up, right? We're seeing all of these potential attacks against all of our applications. And then it was discovered that there's a lot of tuning that would be required to onboard applications to be fronted by a WAF. Now that was 20 years ago. It's gotten a little bit better, but there's still tuning, and I'll kind of dig into that as we go on. So how does it work at a very high level, right? Early on, in AppSec and SQL injection, there was always this, oh my gosh, I can bypass the login, right? I can just add a or 1 = 1 -- and it will ignore the password, and I'll be able to log in as either the first user in the table or the admin if I know the username, right? So how a WAF works is it says, oh, I'm going to look at the input strings, whether it's parameters, whether it's headers, what have you, and it's going to run a bunch of regular expressions and rules against that string. And if it thinks it detects something, like in this case, it would say, oh, this looks fishy, this looks like SQL injection, I'm going to block that, right? Just blindly block it, not blindly, but based on its rules and its regular expressions it's running, I'm just going to block it. So, what if I had the same input box, but now I changed the attack type? So instead of the SQL injection, the or 1 = 1, now I'm going to try something that's more like command injection. Let's see if that's piping it to some command, exe or something like that. So again, what does the WAF do? It looks at that input and says, oh, this looks like command injection. I'm going to go ahead and block it. which for the longest time we're like, oh, this is great, but there were so many bypasses, right? And I'll talk about some of that. So here's this analogy that I kind of like. You know, it makes me chuckle a little bit. But imagine that you own a zoo and you've got these beautiful monkeys, and you know, I've been to a lot of zoos where you can you know, purchase food for the animals. And so you go to the zoo and you know, you own the zoo, and all of a sudden you realize that people aren't just giving the monkeys the bananas that you're selling, they're giving them stuff from off the street and other fruits and other things that you don't want them to eat. So you built this elaborate fencing system that can detect what people are trying to put through it or throw over it. And so it's only going to allow bananas, right? And you're so happy and excited about that because it's going to block everything else and let you know that, hey, these people are trying to feed you know, my beautiful animals things that they shouldn't be fed. So it's similar to a WAF, right? Like it's just gonna like blindly attack the other things based on the rule that you've set that it's only going to allow those bananas to go to the monkeys. So again, how does it determine that attack? You know, at a WAF perspective, for the most part, it's looking at a bunch of regular expressions, and it does these, you know, very, very quickly. You know, it uses some sort of scoring mechanism. You know, if you do some research into how WAFs work and how they've been built, you know, they utilize a fairly structured scoring system. So it's not just like, oh, I hit one regular expression, it's automatically detected as an attack. Right now, it may need to hit a few based on the scores and all of those things. But, you know, you start looking at these, and, you know, I see the one that says on click error mouse clicks. And what that's doing is looking for, you know, on events within the, you know, the HTML. Is that one strong enough? Probably not, right? I mean, the last time we checked, there were like 374 on events, and that one's only detecting 3 of them. So as an attacker, or as someone who wants to feed the monkeys a banana, I just need to find the on event that the WAF is not detecting, right? So, but that's, you know, for the most part, how it's going to determine it. So now as the owner, I'm realizing that, you know, my monkeys, they're getting really bored of bananas, and they're not really enjoying just having them all day, every day. They want some other fruits and some other foods. So I need to tune my fancy schmancy fence that I've put up to allow some other things. You know, maybe I want to allow bananas and oranges and peaches and things like that. So I need to tune that fence, and then now the monkeys are happy again. So how do I tune it? You know, and this is where the tuning comes into play of the WAF, right? You know, it's you look at this and it's like, oh my God, what is that? You know, it's a crazy thing. I mean, this is a mod security rule, right? I think it's for command injection that you would have to go in and either modify or add to your WAF based on, you know, what, you know, maybe you've detected a false positive or a false negative, or you need to tweak something based on the application that it's protecting. You know, maybe it's you know, a specialized application that's doing some things differently than maybe some other just plain Jane, you know, Java app that's displaying a lunch menu or something, right? So there's a lot of this tuning that needs to go on, you know, and there's companies that have built services around just tuning, right? So, but back to, you know, the bypass stuff. So what happens when our fancy schmancy fence says, oh, well, it looks like a banana or an orange and an apple, but what if that apple is rotten, right? What if it looks like an apple, but the fence doesn't detect it as an apple? Or it actually detects it as an apple, even though it's rotten. And now our monkeys are getting sick, right? So that's kind of like all of the tuning that needs to be done, and how hard it is to block all these things. I mean, there are just so many bypasses that we see, and Twitter is just full of them. You know, and a lot of it is context of the backend application. A lot of it is understanding what WAF is being fronted. And it starts to get really, really difficult to keep up with all of the different things that need to occur. You know, so as far as, alert fatigue, we talked about that. There's a lot of alerts. A lot of those alerts, you're not sure what to do with them. Should you do anything with them? Patching fatigue is something that, is a real thing. We had a customer come to us once and they're like, hey, we have our WAF. Here's a list of all of the patches that we've had to apply to our WAF. Does your RASP protect against these? And I got that here in the screenshot. It's like, oh my gosh, they've had to apply a patch to their WAF for all of these different CVEs, common vulnerabilities and exposures. And that starts to get to be a lot. It's like, and some of them may do it automatically. Some of them you may not want to apply based on what the backend application is. And at the end of the day, it's going to possibly stop real traffic, right? I think over time we've gotten better and been able to tweak these rules and things to the point where they're a little more supportive of more backend type systems. I think the OWASP core rule set is very good. If you're using that, I know there's been some studies and tests done in the Azure space that utilize that core rule set that have gotten glowing reviews. But it's not perfect. It will never be perfect. Anyone in this space understands there's always going to be some sort of bypass or modification needing to occur because there's a false positive that's blocking real traffic. And when it comes to bypasses, there's always all these interesting ones. And I threw a couple out here. I just did a quick Twitter search, like WAF bypasses, right? I mean, it's just all over the place of different ways that people have bypassed WAFs, because again, it's all signature based. It's looking for very specific things. So at some point, someone who understands the underlying language, like the SQL interpreter that's being used, is probably going to find a bypass for what the WAF is detecting. So then, as time went on, and we talked about it, like the software security crisis, we started talking about different ways to help protect our backend applications and maybe provide a little more insight into what's going on, in our production environments, in our applications. So this whole runtime application self-protection, or RASP notion, kind of came out a few years ago, right? It's still pretty new, still fairly in its infancy. Lots of different organizations have tried to do it and fell a little bit back to more of the WAF type of approach. But I wanted to kind of go through the differences of what a RASP is versus what the WAF is. So RASP is still layer 7, right? It's still looking at the traffic that's coming into an application. It's looking at the HTTP request, it's looking at the headers, it's looking at the parameters, all of that sort of thing. It still is going to do alerting, right? It's not going to be as much. I mean, the whole notion of a RASP, something that's living in the application, is it should be able to detect attacks at a much more accurate rate than something on the front end that doesn't have the context that a RASP would have, right? From a tuning perspective, it really shouldn't and doesn't require a whole lot of tuning. For most of the, like the SQL injections, the, command injections, patch reversal, those sorts of rules, because the way it does its detection mechanism is a little bit different with regard to its, not necessarily just regular expressions. There may be a plethora of other things that are going on, and I'll kind of, give you guys an example here in a minute. So, some of the differences with this is the RASP has vision into the application. It's living in the application, in the running app in prod, and it's instrumenting the running application in that virtual machine, if you will, which allows it to have more intelligence and more context of what's exactly going on here, and it can allow it to make better decisions, right? Like, is this a SQL injection attack? Okay, if it looks like it, cool, let's follow it through. Is it ending up in a SQL injection sink? Is it being used in a SQL query? Because context is important when it comes to a RASP, whereas a WAF, it doesn't necessarily care about that context. It just knows this looks like an attack. You know, and this, you know, the thing about a RASP is it's like an anywhere type of thing and always on, right? You can move from one JVM to another in a wholly completely different system or cloud, and you don't necessarily have to move the WAF with it, right? So, because it's kind of self-contained in that application. So how does it do it, right? So it utilizes software instrumentation, you know, which is basically debugging to follow the data through the running application. So it can see the data coming in and it can see where it's going out, right? So it can make better decisions on if this is an attack and if it's actually an attack that's going to result in an exploit, right? So remember, we looked at how a WAF works with this sort of input, right? We see the contrast or 1 = 1 dash dash. So if I submit this to a system protected by RASP, if the back end takes that and it says, all right, this looks like a SQL injection attack, but let's kind of look at it further. Oh, it's ending up in a SQL sink. It's actually going to run this as SQL. I'm going to block that. And now you know that, one, you're protected for an actual vulnerability, right? You have a SQL injection vulnerability here. And two, it will allow you to prioritize how to get that fixed, or allow you to push the priority down because you know you're protected. Whereas with a RASP, you just know you're kind of protected, but aren't quite sure if you need to be protected. Here, you know you are. But now if I go and I submit what looks to be a command injection attack against a RASP, against that same field, the RASP is going to be like, all right, cool. This looks like command injection. Looks like they're trying to cat etc password. It's going to follow it through, and it's going to say, oh, wait, no, this is going in a SQL query. This isn't detected as SQL injection. So I can do a couple of things. One, I can just let it go, or I could detect it as what we would call a probe. So someone could still see that, you know, there's maybe an attack here, but it doesn't have to block that traffic. And what this does, and, you know, this is a very specific example, but it also helps with the false positive rate and drives that way down. Because now I can, you know, not detect some things when they're not going to result in an exploit. Because I know for sure with certainty that this command injection attack, it can't result in command injection because it's going into, you know, a SQL query, right? So let's break it down. So I wanted to look at a SQL injection type query, right? So the first thing we need to talk about is a source. So a source would be like a parameter or a header. So, you know, as the request comes into the application, the instrumentation engine says, oh, I see this get parameter. It's a string. I see that come in. It's a source that I need to start doing something with, right? And so then maybe you know, you can see here the get parameter is the user. So now I have this, what we would call tainted input that I need to do something with. I need to do some detection mechanism on that to see if there's a potential exploit occurring or attack and then exploit occurring. And then once I've kind of made that initial determination, so say that I've got this input, maybe I've run some regular expressions and some other detection mechanisms against it to like increase you know, the score or whatever with that input, and will tell me like, oh, I need to follow this now to the actual output. Where is it going to, or something we call a sink, right? So it's going here, as you can see, into the actual query itself, the SQL query or the sink. So now I know that, hey, this is something I've detected as potential SQL injection. It's actually ending up in a SQL injection sink, and I can choose to now do something with that. You know, so one example that we could look at, you know, is, you know, the username and password. The typical approach is select star from users, where user ID equals whatever the user passes in, and the password equals, you know, their password. Very simple approach. This is, you know, way back in the day when you could bypass that whole password with the or 1 = 1 dash dash. So what a RASP will do is it will start taking those inputs, and you can see here I've now added or 1 = 1 and some potential commented blocks and things like that, and it will start breaking down this query. and it will say, okay, cool, I've got my select statement, I've got the result, table ID, so on and so forth. And it can look at this and it can start tokenizing it. And it can understand and realize when some boundary is crossed. That user ID, it should just be a literal, right? So if more than what's being passed in is more than a literal, in this case it is, right? There's an operation, there's a new expression, it changes up the where clause. I can detect that potential exploit at this point, right? Because I know that there's a massive boundary crossed here where I'm expecting a literal only, and I'm now doing some other things that wasn't expected, which is what it's trying to do here and comment out that password block. So just going along those same lines, I can now look at this and be like, oh, there's multiple things here. It's expecting that literal. I have an operation, I have an expression, and I have another comment block that none of that should or was there in the original intent of that query, right? So with a RASP, now I've got this input, I have a result set, I analyze that query, and I've detected that, oh, damn it, it's crossed a boundary. I'm going to do something based on the action that the user has set and send an alert somewhere, right? So the accuracy of that alert is much, much greater and better than something coming from a WAF. And it would allow me to take action on it, whereas some of the alerts from a WAF may not really give you any actionable thing than maybe just blocking an IP address because maybe there's just a bunch of traffic coming in. Because you're not sure if it's resulting in anything. This one, you can very confidently say that if I would have let this go, it would have been an actual SQL injection exploit. So, what it comes down to is it's kind of like the continuous security in your car, right? Like think about all the instrumentation that are in your vehicles and airplanes and things like that today, right? We're instrumenting everything. How many of you have tire pressure gauges in your vehicles, right? It gives you that instant feedback, and for sure that, crap, my tire pressure has just dropped significantly. I probably need to go get that checked and do something about it right now, right? Whereas the old approach was you would just kind of, get out of your car and notice that that tire might look low, or, like the WAF approach, someone in the car next to you says, roll your window down and tells you your tire is low, right? It's not the instant feedback that you would know right now. It's the next kind of person that may look at it and tell you that. From a perspective of what it looks like compared to what a WAF is, I turn the rule on, right? So I have command injection rule, cross-site request forgery, cross-site scripting, so on and so forth. I turn it on or I turn it off. Maybe I want to have it in monitor mode. Maybe I want to have it in block mode, whatever it might be. But there's not really any extra tuning to go. I'm not making any tweaks, to the system at all, really. When it comes down to it, it's kind of an on or off type of thing. However, there are still downfalls, right? And would behoove me if I didn't talk about them. Since it is running and instrumenting an application, right? It's very, very language and framework specific. So you can imagine the amount of development effort that's required to support even a point release version of not only, say, Java, but Spring, right? Like supporting Java is one thing, maybe supporting Java 8 to 9 or 10 or 11 is one thing, maybe supporting Spring 4 to 5 is one thing, and you start adding complexities to that sort of support, right? Any sort of bypass, which again, RASP isn't going to be perfect. There's going to be bypasses and there's going to be false positives, but hopefully they come in much, much, much lower rates than your WAF. When they do, a lot of times it would result in code changes. Because remember, it's an agent of some sort that is instrumenting your application, and that agent would need to be possibly updated depending on where the fix needed to occur. Sometimes it's a lot more difficult to install. A lot of times the WAF can just be front-ended in some Nginx or some sort of server on the front end. whereas this is running in the VM of wherever your code is running, right? So, if your Java is running in a WebSphere or WebLogic context, your agent has to be running there alongside it. And sometimes that's a little more difficult. However, in more of the DevOps automated type approaches, it works fairly well. And another thing that commonly is run into is oftentimes you don't see anything, and you're not sure if it's actually doing any protections, because in a WAF, we're so used to a plethora of stuff and seeing all these things, regardless of any actionable items that come out of it. We're used to seeing all that stuff. So we're so used to it. It's like, oh, I got my RASP going, got it installed, it's running, and I'm not getting attacked. Okay. And that's okay, right? You shouldn't see nearly as much. And actually, you should see quite a bit less. Because remember, it has that context of what it's actually detecting as an attack and a potential exploit. And the great thing about RASP is, it's already a standard. It's in the 853 PCI. They're talking about adding it to some of the, SAM and things like that as well. So it's definitely something, to think about. So let's compare the two outside of just talking about them separately, right? How are they similar? How are they different? Is there a way to compare them? I think you probably understand that there's some differences that kind of went through separately. And you can see from this that, from an architectural standpoint, this may not look too different, but it's dramatically different. Because the WAF is kind of front-ending things and could be front-ending a lot of different applications. It could be the only entry point into your network that's front-ending your whole entire application space. Whereas the RASP, it's on an application. So what we're seeing a lot of, because we're in this space. I've been in this space for a while. I've looked at WAF, RASP, and all that. Is organizations will try to pick one or the other, right? Like, let's do a WAF or a RASP. But I'm not sure if that's the right thing to do, and let me tell you why. So as you can see, the architecture is different, right? And what I went through already is kind of explained the differences. So a lot of the analysis that organizations are doing for WAF versus RASP is they're just taking a bunch of payloads. So maybe they go download, some payload generator, and they just throw it at these dummy applications. Those dummy applications may just be an endpoint that's just listening and not doing anything, right? So now understanding what a RASP does, do you think the RASP is going to detect anything? And I'm hoping you're all saying, well, no, of course it's not, because if doing nothing on the back end other than just listening, it's not going to detect and do anything with that stuff, right? So, more and more orgs are starting to do a little bit better payload type testing. But, one case study that was kind of done was, look at SQL injection, command injection, XSS, file patch reversal, right? Some of these things that are the most egregious things that organizations probably care about. And you can see here the scan count, that's the different payloads that are being sent, and then block count. So now I'll take a step back and look at these numbers and digest it. Like, what do these mean? I hope you're saying they don't mean anything. And I agree, because one, I don't know what the payloads are. I have no idea what the payloads are. Two, what does block mean? Does it mean that it detected it and just blocked it? Does it mean it detected it and said it was a probe? Are you submitting the request to an actual vulnerable endpoint for that specific vulnerability? Right, so you can take a little bit from this, but for the most part, these results don't really tell me much at all, because it's almost like I'm testing two different systems that do, frankly, two different things, and they're protecting at different levels in an architecture, right? So the results are kind of all over the place, and the testing methods really aren't consistent. Some people, like I said, they're just throwing it at a backend that just has, an open web port that's just listening for requests. So our internal research team looked at a bunch of payload tools. Some of the more commonly used ones. We actually had a customer that said, here's all of the tools and all of the payloads that we use to evaluate WAF and RASP. I'm like, cool. So we'll start looking at some of those, and we really dug in because I really wanted to understand. Again, I'm a big data person. I really want to understand what these payload tools and lists were and what they did. And what it came out to be is, number one, a lot of these payloads aren't valid, or they're very much duplicated across payload lists, or they're out of date. There's some payloads that haven't been touched in years. I mean, there's some payloads that are from like Netscape. Like, do we really need to detect those anymore? Probably not, right? So, with regard to XSS, it was probably the better of all of them, probably because XSS may be a little bit easier to quickly determine if an application is vulnerable to it, right? But still, 20% of the payload list itself was not valid or duplicate. So if we go back a slide, what if those scans and those payloads weren't even valid in the first place? Because I'm just pulling them out of a payload list. So then you start breaking it down even more, and you look at SQL injection, 27% of them weren't valid. Command injection, 48%, and patch reversal, 82%. And most of that was duplicates, right? If I'm going to detect ... I'm probably going to detect ... right? So it's disingenuous for both a WAF and a RASP to just blindly start throwing payloads and data at a backend, dummy application or insecure app, and try to compare those numbers, because there's so many things at play here that aren't really providing that whole picture of the strengths and weaknesses of each of them, right? So, I think having that visibility through data is important. And the way we think about this data that's really coming in, and how we classify the important data that we're seeing. And you look at the way that we're currently doing it with our WAF, right? We have our SAST and DAST type scanning. We have all of those results. So we have all of our vulnerability data. We have it in some tracker or trackers. We're doing it in our sprints. We're fixing things there, and then our applications get pushed to prod. And as we said before, we know applications are vulnerable, right? We're not fixing everything right now. The average mean time to remediation, of applications is, significant for the most part. It's over 100 days, industry average. So we know that we're running vulnerable applications, but we don't have any insight here, because all we have is our WAF running that's probably pumping things into our SOC or SIM or logging mechanism, right? So then with RASP, we're now able to, more closely correlate some of that data and help with some actionable items. Now, is this bad to have this data? Heck no. Like, from a threat intelligence standpoint, I still want WAF data. I still want to know if I've got some massive DDoS or scan attempt, or, I'm seeing all sorts of things come from some of the container orgs out there, for XSS and whatever else. I still want to know that stuff. But I also want to look into my app, and I want to see what things I'm vulnerable on, or have vulnerable components in, and block those things. And it will allow me to not only know that I have vulnerable applications, but knowingly prioritize fixing of vulnerabilities, still moving them into prod, right? And knowing that they're going to be blocked, right? Because I've got my RASP running, and I'm able to correlate that data back to, my SAST, IAST, DAST type data. So one analogy that I kind of like to use here, and you probably kind of see where I'm going with this. I truly believe that the WAF and the RASP have a place in our security tool belt. I think that each one of them has, pluses and minuses as far as, what they're good at, what they're not so good at. I think they work extremely well together. as well, right? You know, the WAF is very noisy. You know, that could be trimmed down to something where I'm just correlating for some higher level of threat intelligence. It requires a lot of tuning. Whereas, you know, if I have the WAF and the RASP running, maybe I don't need to tune it as much, because I know if there's a bypass of some sort, I know that the RASP should detect it and catch it. So it's kind of like a, you know, that whole stacked methodology of, you know, having different layers of security controls at different places in the ecosystem. So, you know, what it comes down to is I like to, you know, have it, it's more than an analogy, but you think about AV, right? Antivirus has been around forever and ever. I think in the security industry, for the most part, we complain about it. Oh, it's not good enough. It doesn't do a very good job. It's all signature based. You know, once you're past it, it's game over. And it's been like that forever. You know, I think there were quite a few years there where the AV space was very bloated. It got really, really expensive very quickly. And it started getting to the point where even security professionals were like, we got to weigh the cost and the benefit. And then people like Microsoft were like, oh, here's some free AV. Just go put it on all your Microsoft machines. And that was quote unquote good enough, right? Because it did the same sorts of things. It had signature-based detections. It updated quite frequently. And it still provided that not only that check the box, but it was still one control. And this went on for quite a few years, right? Then we moved slowly to the right a little bit, right? So we went into more of a next gen antivirus. There's more advanced features. Things got better. It was still mostly signature based. You know, there's not necessarily always going to be as many updates because it's doing things a little bit differently. It helped to close some of those gaps that it previously had with just your basic antivirus, right? So you're starting to see where we're trending here, right? So then we get more into the right side with EPP, NGP, and now EDR, right? Where we have basically instrumented these endpoints to detect and contain security attacks and incidents. We know that someone's machine's now been compromised with some CNC, right? We know how to stop it and prevent it and sandbox it and notify the right people with the EDR. And this is going to be similar from AV, aka WAF, to EDR, aka RASP, right? So that's one way I like to look at it. You know, it's not a perfect analogy, but it does show that they are really different technologies in what they're doing, right? Now, do you have both AV and EDR? Some people do. Is that the right approach? It might be. It might be the right approach for you. I think it's the right approach with a WAF and a RASP. So the one thing that really gets to me about security in general is MTTR and how quickly we can get things fixed and patched and all of that. So, you know, what was it, 5 years ago, maybe not that long ago, we started talking about this whole shift left momentum, you know, move things as far left as possible. Let's talk about them as early as possible. You know, let's get integrated IDEs, and all of that's great. And I think it's allowed us to make strides in not producing the same amount of insecure software as we used to, but it also only works well in the DevOps and Agile type environments. And there's still, frankly, a lot of more of the antiquated waterfall approach. It's tried and true, it works, and that's what some people are used to, and sometimes change is hard, and speed is sometimes the enemy, right? So the whole shift left movement didn't necessarily work as well for everyone. And so hackers exploit this lag, right? So you look at the CV 2017-5638, it was an Apache struts issue. This is what Equifax was breached on, right? So, a CVE was issued on March 7th. And for the longest time, for that first day, we started detecting attacks and probes and stuff for this specific attack. There were proof of concepts. It was something that was, quote unquote, easily exploited. And then there were like no updates, and then mid-May, so you're talking, a month and a half, 2.5 months, right? No updates, no detection, a breach occurs. That breach resulted in the compromise of lots and lots and lots of accounts. And then July 29th, which was many, many months later, is when Equifax learned about it, right? And then September 7th is when they disclosed it. So you look at that timeline, right? And you start to say to yourself, the shift left movement wouldn't have necessarily fixed this, right? A CVE is released. There's probably a fix, right? Apache fixed that version. But now I've got to go and update that application server or that web server. And I got to make sure I update all the ones that are vulnerable. And there could be hundreds, there could be thousands in my environment, depending on what the environment looks like. And if I don't do it right now, attackers have that time to now exploit that leg. So we've traditionally used a WAF to help bridge that gap, right? But some of these CVEs, lots of them are, EL injection or deserialization with RCE, or remote code execution, aren't easily detected by a WAF because they need the signature to detect maybe the serialized version of something, right? So then we're reliant on the WAF to go and make some patch, or someone to go to their WAF and create their own patch to prevent this attack from occurring while they get their servers updated. But if I had a WAF and a RASP is really good at some of those more esoteric, not necessarily signature-based type of attacks and exploits, right? Your deserialization stuff, your EL injection stuff, maybe some of your XSS and patch reversal, depending on bypasses and things like that. It's really good at detecting those because it can do it in a way where it tokenizes that input and it can detect the boundary crossing and really prevent those things. So I can utilize the control system here and know that I have my WAF and I have time to patch that, know that I have my servers and that there's a patch out and I have time to patch those because I have my RASP running, right? So having all of those is important because it provides us that layered approach to security, which we're all used to. So, what it comes down to is, normally if I was sitting in front of you, I'd be like, all right, who here would rather have an airbag or a seatbelt? And I'm sure both of you, or however many of you are listening, are like, oh, why do I have to choose? And that's exactly right. Why do I have to choose? Why can't I have both? Sure, the seatbelt might be annoying, right? Because you might brake a little too hard once and then it gets kind of stuck or whatever, right? Or rubs wrong from long driving and things like that. But you always feel it. You're always getting those quote unquote alerts. But the airbag really saves you when it needs to, right? When you run into something, when you hit a truck or get hit by someone, that's when it detects it and it deploys it. And it protects you that way. So it's prevention and protection, which is very similar to what I think with WAF and RASP would work well in our environments. And I'll leave you with this. Like I said before, I think the strengths and weaknesses of both of them really work well together, right? And allows us to help bridge the gap of vulnerabilities and CVEs and things that come out that we may not have the time or can't get to it as quickly as maybe the malicious actors can, right? Both of them have strengths. Both of them have weaknesses. And we've talked about all those at length. And I hope you can see that, in the security space, we continually talk about control layers. And I believe extending right, not just shifting left, is definitely something that we have to continue down this path. We're instrumenting everything else. Let's do it and continue doing it in prod. And I thank you. I don't know if there's any questions. Let's see.